Hello, good morning everyone. Once again, welcome to the world of electronics. Our lesson for today is a sequence of the lesson that we had last time. That was all about switch mode power supply. You have learned class that this SMPS circuit is composed of two sides. We have the hot side and the cold side. It is hot side in the sense that it processes higher amount of voltages from 100 volts up to 350 volts. You can be electrified once you touch any of the components here. Whereas here, the cold side is processing only a lower amount of voltages from 2 volts to possibly 40 volts. Besides, the two circuits are actually isolated to each other or separated to each other with the application of this optocoupler. Actually, the symbol here for the ground symbol is earth ground. And we have here the chassis ground. Earth ground in the sense that one of the lines of the AC power line is connected to the earth. That is why there is a big possibility that once you touch any of the components here, since it is connected to the ground or to the earth ground, you can feel an electric shock. Whereas here, the ground actually is chassis ground, which is connected to the metal case of the unit, such as DVD player, TV receiver. That is now the symbol, chassis ground. Okay? We can actually verify if the two grounds are separated to each other. Using ohmmeter, we set it to times 1 ohm. We set this one to times 1 ohm to identify the continuity of the two grounds. Okay? We have here the hot ground, our hot side, and the ground here is over here. On the cold side, the ground is over here. So let us measure if there is continuity with the two circuits. So there is none. There is no deflection of pointer. That would mean that there is a continuity with the two circuits. They are actually isolated and separated. That's the reason that you cannot be electrified once you touch any of the components here, because the two grounds are separated to each other. Okay. Aside from that class, this SMP circuit is composed of two power stages. The first power stage and the second power stage. The first stage actually is the conversion of the AC volt here. The 230 volts with a frequency of 60 Hz is actually converted into DC by means of the rectifier diodes. And the frequency here is 120 Hz. And the voltage here is somewhere at 325 volts. So, AC to DC, that is the first stage. The second power stage is the conversion again of this 325 DC volts into DC volts again, which is lower amount of voltages. From this diagram, of course, we have 14 volts and 5 volts. These are the desired lower amount of DC voltages being converted from the 325 volts DC into 14 volts or 5 volts DC. So, the possibility of converting DC to DC is made possible of the switching transistor here. Actually, this IC is a control IC built in with switching transistor. The transistor actually is a MOSFET transistor, which is metal oxide semiconductor Philippine transistor. It goes like this, class. Okay? We have here the switch mode transformer. And we have here the DC volts, 325 volts DC across this capacitor here. Okay? The transistor actually is over here. Okay? It goes like this, class. Okay, we have here the drain, the source, and the gate, which is built in by this IC. So, we have here the earth ground, and the voltage is over here, the positive side of the voltage. And we have here the winding, secondary winding here. There are two windings, since there are two outputs of this switch mode transformer. Okay, the conversion of this 385 volts DC into DC voltages, a lower amount of DC voltages, are actually made possible by means of the switching transistor. This transistor switch on, switch off, switch on, switch off. The turning on and the turning off of this transistor actually is being performed by this oscillator here. There is a so-called pulse generator. Pulse generator as what we have here. These are the pulses. On, off. On, off. So this is the on state and the off state. This is now the pulses being fed to the gate of this MOSFET. Remember that there are 3 electrodes of this MOSFET or transistor. We have the gate, corresponds to base of the bipolar junction transistor. We have the drain, corresponds to collector. And the source corresponds to emitter. Okay. Once this transistor will be turned on once this pulse is fed to the base or to the gate. But once it is here, the transistor cuts off. So the turning on and the turning off of this transistor is very important for the conversion of this 385 volts DC into a lower amount of volts of DC. Okay, it goes like this, class. So what is that pulse generator? Actually, you have here the pulse generator that provides pulses to the gate of this transistor. Okay, we have here the negative side and we have here the positive side. Okay, it goes like that, class. On, off, on, off. Transistor is on, off, on, off, on, off. In such a way that this voltage will goes up 325 volts, then goes down to 0, 325 volts, 0. So the voltage here should be varied in such a way that it can be transformed to the secondary. So it goes like this, class. It goes like this. We have here okay. We will connect this one to the voltmeter AC. Okay, we have here voltmeter AC. Then let us connect this winding here. Actually, a transformer is composed of 2 windings, the primary and the secondary. Actually, the 2 windings or the 2 coils are not connected to each other. So we will supply this one with DC volts here using this battery again. Okay. Okay, try to observe this tester, class. Observe the tester here. Okay. We have here the positive side. And the negative side is over here. Once the voltage that is fed to the first coil is DC, so there is no transformation of voltage at the secondary because it is fixed polarity. But once you on and off, see, there is transformation of voltage from the primary to the secondary. It is on, off, on, off, on, off. Okay? It goes like that. Once you vary the voltage here, on, off to 90, 90, 90 by switching on, switching off, switching on, switching off. But if you permanently connect that, there is no transformation of voltage in the secondary. So, that is now the operation of this transistor here. Once the pulse is entering to the gate, Okay? Once this pulse enters the gate, so there is a flow of current here. So there is voltage. But once it pulls down here, 0 volt. So there will be no current circulating there because it is 0. On again, off, on, off. So the turning on and the turning off of this transistor here, which is internally connected here in this IC, is made possible by the pulses. Okay? How many times should the transistor turns on and off? That depends upon the frequency being used by this second power stage. The first stage using 60 Hz being converted into DC, but the frequency doubles to 120 Hz. But here, the frequency being used here depends upon the circuit. The frequencies are ranging from 20 kHz up to 1 MHz. That depends upon the brand or the model or the type of the circuit. So let us assume that the frequency being used here to turn on and off the transistor is 20 kHz. So the transistor turns on and off 20 times a second. In 1 second, it turns on and off 20,000 times a second. No? Okay. It goes like that, class. Okay, let us now come to here. What is this circuit here? This circuit actually is a snubber circuit. Snubber is N-U-B-B-E-R. It composes of a resistor, a capacitor, and a diode. It is a network of snubber. The purpose of this is to neutralize the voltage spike. Because without this circuit here, there's a big possibility that this IC will be damaged. Why? Because of the voltage spike. How much would be the voltage spike here that enters the circuit of IC? It doubles the voltage here. If the voltage here is 325 volts across capacitor, because capacitor here actually stores voltage up to the peak value, so there's a possibility that the voltage here is 325 volts. But during the turning on and turning off of the transistor, there is a voltage spike that doubles the voltage. 325 plus 325, that would be 650 volts. Then, without this, there's a big possibility that it will enter the circuit of the IC, and the IC will be damaged. So, snubber circuit is installed in such a way that it prevents the entrance of the high voltage to the IC. So, what is that voltage spike? By the way, class. So, it goes like this, class. Okay? We have here. So, let us connect the connect this one here. Then, let us connect this one again to the analog multimeter. Analog multimeter. Set that one to AC voltmeter, 10 volts. Then, we will use this alligator clip. Connect this one here. Then, the other terminal here is connected here. Okay. Let us observe the condition now of this analog multimeter which is set to 10 volts AC volt range to measure the voltage outputted by this coil here. So there is no voltage spike, but anytime there is 325 volts here. It is turning on. But anytime that you turn off the transistor, that is voltage spike. Okay? See? Okay. There is no deflection pointer. Once the battery is permanently connected to the coil. But anytime that you disconnect this one, see? The pointer deflects during the disconnection of this terminal from the battery. So we call that one voltage spike. There is no voltage spike here once it is permanently connected. But anytime that the voltage drop to 0 from 9 volts here or from 3 volts drop to 0, when it drops to 0, there is a voltage spike. That is now the characteristic or the behavior of the inductor. The inductor has an inductance in Henry, millihenry, microhenry. Because inductance is a property of a circuit or circuit element that opposes any change of current. Because when you disconnect, there is current here. Direct current. But anytime that you drop the current to 0, there is an opposition to the change of current there. So anytime that it drops the current, there is a so-called induced voltage that will support the decreasing current. No? Because when you disconnect, that is decreasing the current to 0. Anytime that the current decreases to 0, there is a so-called induced voltage. We call it counter electromotive force that will support the decreasing current. So, that is now the purpose of this snubber circuit, to neutralize that voltage spike. Because without this voltage spike circuit, or the neutralizer of the voltage spike, there's a big possibility that the IC will be ruined, will be damaged. No? Any of the components here, if this capacitor is removed, this IC will be damaged. Okay? We have here actually the circuit here. This one is the IC, the control IC, with built-in MOSFET transistor that turns on and off. And we have here the snubber circuit. We have here the 56 kilo ohms, because this diagram is not the circuit of this board. So 56 kilo ohms. And we have here the 3.3 nanofarad probably. And we have here the diode here. This diode actually here. So this network will constitute as a snubber circuit that will neutralize the voltage spike that will exist during the turning on and off of the transistor. Okay?